Good afternoon, I am Renu Sharma. Today we will start with the third lecture of wireless and mobile communication, and the topic of today's lecture is cell theory. So, these are the contents of today's lecture, that is introduction to cell theory, cell infrastructure is there, cluster of cells and cell frequency reuse. So, basically any geographical area, let us say this particular city is divided into different cells. The shape of the cell is important, the size of the cell is very important. It will going to vary depending on the population which it will be going to cover in terms of cells. We will discuss in lecture. So, introduction to cell theory. The concept of trunking or resource sharing between two central telephone exchanges was used in conventional landline telephone systems. So, in the conventional landline telephone systems, there is a center unit which will going to connect to landline phones for the purpose of communication. So, when we are moving towards this mobile second generation, that is GSM, global system for mobile communication, that is strictly designed for the mobile phone use. In that case, the purpose of transmission will be performed using wireless condition and secondly, there is no intermediate node is there. It has a BTS that will act as that is an antenna which will going to transfer the signal from one mobile phone to another mobile phone. The trunked radio system is complex centrally controlled full duplex radio system that allows sharing of limited radio frequency channels among a large group of users. So, it uses control or signaling channel as well. So, basically in case of cell theory, every area, let us say this area is divided into this cell. This is the shape of this cell which has a centered excited BTS. That is nothing, it is an omnidirectional antenna. If it used at the center, then it will be an omnidirectional antenna. If it is used at the edges, then it will be a directive antenna or directional antenna which will going to radiate only in one direction. That is the use of this directional antenna. So, that is introduction to cell theory. Now, next is cell theory. The concept of cell technology encompasses various aspects of infrastructure, for instance, division of area, frequency management, allocation and call handling. So, these are some of the key points when we are dividing an area into different cells. Frequency reuse is the first most important concept, because in case of mobile communication it is full duplex, totally full duplex, where the information will be transmitted from base station to receiver in forward channel and from mobile to base station, that is a reverse channel. So, in both for both the channels, for both the transmission, set of frequencies are allocated for every user. So, that set of frequencies, how much frequency has to be allocated and how that frequency can be reused. Reused concept is very important. We will discuss later in this lecture that how the frequency can be reused, because at some point of time it is not always possible that the allocated frequency will be used for particular transmission. It is possible that it will be used after some time. So, that is the case for frequency management. Now, next one is division of area. How the area will be divided, what will be the radius of a hexagon, that point has to be kept into mind depending on the population. Let us say I am dividing a rural area where the population is very less. So, in that area the cell size will be increased, because it can cover the large number of large distance, but smaller number of people are there. So, it can be perfectly possible or perfectly it is feasible to divide the area into large area for less population. It is inversely proportional. If the population is quite large, then it cannot be accommodated, it cannot be supported by a very small cell size, it has to be increased. So, that is why the cell size should be reduced. So, following are the two major components of the mobile telecommunication system in general. First one is the central station. So, this is common for many subscriber and includes the switching equipment and an RF transmitter and receiver. Mobile telephone, every subscriber must have a mobile telephone that includes a microphone, a speaker, a dialing facility, radio transmitter and receiver. So, these are some of the characteristics, or you can say some of the points that are required for the mobile telephone system. This is the central station. So, these are some of the key points, key terms that is related to cell theory. Now, cell infrastructure. In modern cellular telephony, rural and urban regions are divided into areas according to specific provisioning guidelines or standard protocols. Deployment parameters such as amount of cell splitting, cell sizes are determined experimentally in the cellular system architecture. So, provisioning for each region is planned according to an engineering plan which includes cell, its cluster, frequency reuse and handovers. Let us say 100 kilometer of area is divided into 7 cells. Okay. So, 7 cells are closely related to each other. We have to decide the radius of each cell, so that the cluster of or the collection of 7 cells will going to cover the 100 kilometer distance, 100 kilometer of radius of distance. Then we have to decide that what is the range of frequencies that has to be allocated for a set of frequencies or pair of frequencies has to be allocated for the base station and mobile phone, so that it can transmit or receive the information. And also, let us say I am deciding over here, I am allocated to a single cell from a particular cell, and I am moving for some days or for a holiday, for a vacation to an other cell. So, my control signals, my information, that is the authentication information, that is a part of GSM model only, will be transferred to the visitor cell, visitor location register, VLR, from HLR, that is the home location register. So, it has to be transferred from one HLR to VLR. Let us say this is a cell of this geographical area and I am moving to this cell of another geographical area. So, the control signals, the voice signals, whatever information I am having, the authentication signal, this is nothing, it is HLR, and this is nothing, it is VLR. So, for some point of time you are familiar with the term roaming. My phone comes under roaming, which means the I am visiting a particular different location. So, that is a visitor location register, that is the transferring of control signals or voice signals to another location. So, that during that if I am moving, if I am on a call and I am moving from this place to this place. So, during the call it may be possible that handoff or handover will not be done perfectly. So, in that condition call termination will take place, call will be disconnected for some point of time, because the particular it is not smooth, the handover is not smooth, it is having some glitches. So, that is why handover plays a very important role. Also, today's software tools are also available to plan and design the cellular architecture. So, earlier when this is GSM model, in second generation it was introduced, it is a very what you can say, it is a very hectic plan or hectic schedule to divide a geographical area into different cells, and we have to decide that what will be the what are the cluster, what is the size of the cluster that we have to consider, what is the radius of that particular hexagon that we have to consider. So, that is the condition that we have to keep in mind, but today it is all software dependent. Now, cell is a basic geographical unit of a cellular system. The term cellular comes from honeycomb hexagonal shape of areas into which a coverage region is divided theoretically. Cell wise, one base station provides transmission over a small geographical area. That is why I have told that it is excited in the center of the cell, or it can be excited at the edges of the cell. Directional antennas has to be used. Cell sizes varies depending on the landscape, topographic locations such as mountains, valleys and plains, because we have to consider these atmospheric conditions also, because it is not always possible that direct line of sight will exist between the transmitter and receiver. It will not be always possible. So, to overcome that, we have to see that what are the possible ways, so that the good quality signal can be transferred to the receiver side. So, due to the constraint imposed by the natural terrain and man-made structures, practically the cells are not perfect hexagon. So, theoretically it is a hexagon, but due to the terrain, let us say I am dividing this area into this cell. So, while dividing this, there is a tree or there is a very massive building is there, which I cannot ignore, and it will going to interrupt the transmission. So, that area can be converted like this, hexagon can be converted like this. So, this will be reduced. So, that will not a perfect hexagon, theoretically it is a perfect hexagon. So, this is the cluster of cells what I was talking about. Cluster of cells means a group of cells that can be used to cover a particular geographical area, and to this cluster I have we have to allocate some set of frequencies, and then we have to decide that what set of frequencies can be reused after how many gap between two cells. So, first figure illustrates a 7 cell cluster. This is a 7 cell cluster, you can calculate, this is 1, 2, 3, 4, 5, 6, 7, which means this is a structure which constitutes 7 cells. And how we have to decide? This is decided by this formula, that is very important formula, n is equals to I square plus j square plus I j. What does it mean? This is nothing, these are two integer values that has to be positive, that can be 0 also, that cannot be negative. So, I and j should be positive. This is the basic idea behind choosing the value of I and j. I means I times you have to vertically move, j times you have to rotate 60° clockwise direction and move to that point. Let us say I am using I is equals to 2, j is equals to 1, which is shown in this diagram also. I have started from here, then if I is equals to 2, then we have to move vertically upward 2 points and reach to the center of that cell. So, this is first point, this is second point, then move 60° clockwise direction and move to j is equals to 1 to this direction. So, this is cluster 1, this is cluster 3, this is cluster 2. So, which means it is 7 cells, this one, this is 7 cells, and this also constitute the 7 cells. So, these are the basic clusters. So, two non-negative integers, that are I and j, determine the relative location of co-channel cells. This is vertically we have to move, this is slant horizontal move. So, this is I is equals to 1 and j is equals to 2. So, that is the use of reaching to co-channel cell. What is co-channel cell? When two cells are using same set of frequencies. So, that is why we have to decide that this cell and this cell is using same set of frequencies. So, that is why we have to, that is how we have to allocate same set of frequencies. So, this is the idea from where the frequency reuse concept is used. Now, we have to decide the cell size, which is directly dependent on density of subscriber in an area, or in short form we can say population, which can be an urban area, which can be a rural area. So, two areas are possible depending on the population. Urban areas, which means that larger number of subscriber reside at that place. In case of rural area, less people are residing in that place. So, the capacity of a network in a densely populated area can be improved by reducing the size of the cells or by increasing the number of cells along with installing low power base station. This will basically increase the number of channels in that area because of more frequency reuse. So, on the basis of their size, cells may be categorized as macro cells, micro cells, pico and femto cells. So, basically I have told you that it directly related to the population. it is related to microcell, picocell, femtocells, which means that it is deciding the radius of this hexagon. Let us say this is an hexagon, this is the radius, because at every point it is the radius will be same. We have to decide the value of r. R will be dependent on macro cell, and from this macro cell to femtocell this r will be reduced. So, this is how we have to decide the size of the cell. This is cell splitting. Cell splitting is directly dependent, like large cell are used for rural area and small cells are used for urban area. So, that is indirectly proportional. Larger the population, smaller will be the size of the cell, and smaller the population, larger will be the size of the cell. So, this is seen over here that the radius of this particular cell is large as compared to this cell and as compared to this cell. So, this is R1, this is R2, this is R3. So, R1 is greater than R2, it is greater than R3. So, you can clearly find out this is used for the urban area, rural area, and this is designed for the urban area. So, this is how you have to decide the size of the cell splitting. Now, the frequency reuse concept. A radio channel consists of a pair of frequencies for full duplex operation. So, radio channel means when we are talking about mobile communication, in mobile communication the pair of frequencies has to be allocated, one for base station to mobile and other is for mobile to base station. So, this is the set of frequencies that has to be allocated. So, the concept of frequency reuse is based on assigning to each cluster the same group of radio channels used within a small geographical area. A set of n different frequency groups like F1, F2 up to Fn is there, which is used for each cluster of an adjacent cells. So, it will be shared among the cells and amongst equally as it is possible. In figure second I am going to show you. So, this is how you have to decide or divide a particular area into different cells. So, the set of frequencies assigned to a cell is completely different from that assigned to the neighboring cell. So, this is how you have to divide a cell into different neighboring cells, like set of frequencies, it will be divided into different cells. So, this is figure second, which is showing that this is showing the cluster of 3 cells, like these are the 3 cells which are connected together. This is a cluster of 3 cells again, this is a cluster of 3 cells again. So, this is how you have to divide the cells into different clusters. Secondly, you can divide the cells into 7 cell cluster also, like this is a 7 cell cluster, this is a 7 cell cluster and this is a 7 cell cluster, where 7 cells are interconnected together, and you have to decide that which cell has to use the same set of frequencies depending on the formula, which is written as n is equals to I square plus j square plus I j. I means you have to move vertically upward and to that point, and then rotate 60° clockwise and then move to j location. So, that is how you have to decide the frequency co-channel cell. So, this is the frequency reuse formula, that is very important. We will see. Let L is the total number of duplex channels available for the frequency reuse, that is frequencies per cluster. K is the number of duplex channels that is allocated to each cell of a cluster, that is K is less than L. So, basically number of duplex channels which is allocated should be less than each cell, that is the cluster, K should be less than L. Then n is the cluster size in which there are n number of cells are there. N number of cells means how many cells are there in a cluster. Like in the previous slide I have told that there is a 3 cell cluster, which means n is equals to 3, 7 cell cluster means n is equals to 7, it depends on the values of I and j that you will consider. Then m means number of times that particular cluster is repeated. Let us see in this example that this cluster is repeated 3 times. So, m will be is equals to 3, n will be is equals to 7. In this case, it will be repeated 1, 2, 3, 4, 5 and 6. So, which means m will be is equals to 6, n will be is equals to 3. 3 cells in a cluster and it will be repeated 6 times. So, this is how you have to decide the value of m and n. Then C is the total effective number of duplex channels available in the area. So, the formula for L, which is related to each other, then L will be is equals to K into N, and then you can find out the capacity, that is C, the total number of effective duplex channels. So, C will be is equals to M into L, which can be related as M K N, that is total effective number of duplex channels available in this particular area, which is denoted by C is equals to M multiplied by K multiplied by N. So, C is equals to M K N. So, this is the total effective number of duplex channels that is available in that particular area, and L is nothing, it is the total number of duplex channels that is available for the frequency reuse concept. So, this is all about the frequency reuse, that what is the frequency channel that we have seen. Also, one thing I want to clear, that the model which is considered for the mobile communication, that is global system for mobile. So, this is the base of the mobile communication. In this, there is a mobile phone, that is mobile equipment added with a SIM. So, mobile equipment is there added with the SIM. So, this has to be connected to more than one BTS unit. These are nothing, these are the BTS units. This is nothing, it is the BTS unit. So, to this point there are different BTS units are connected. Then these BTS units are connected to MSC base station, to one base station. More than one BTS is connected to one base station, and more than one base station is connected to single MSC, that is mobile switching center. So, this is the flow of GSM model. More than one MSC, it can be extended to here. So, more than one MSC is connected to one GMSC, and this is connected to this PSTN, it is connected to subscribers or any outside world. So, that is GMSC. So, this is the flow, that mobile phone, more than one mobile phone connected to one BTS, more than one BTS is connected to base station, more than one base station is connected to MSC, that is the mobile switching center, and more than one MSC is connected to global mobile switching center. So, this is the global system for mobile communication. So, two non-negative integers we have to consider. So, this is the main idea behind a cell, behind a mobile phone GSM model, that is strictly related to 2G. It has two set of frequencies, one is for forward channel, that is 920 megahertz, if I remember correctly, it is 920 megahertz to some 1015 megahertz, and other set of frequencies are located for the reverse channel. And in between this mobile phone BTS or BTS to base station, there are various interfaces are there, air interfaces, which will going to connect this BTS to BS or this BS to MSC. So, there are various interfaces which will going to connect this MSC to GMSC also. So, these interfaces will you also have to consider. We will discuss this GSM in detail in next lecture also, which is a very important topic related to this mobile communication, because this mobile communication is dependent on this model only. So, this is all about today's lecture. These are the references that you can consider for this topic. Thank you.